Hey guys, today we're doing Chapter 4, Section 10, which is on modeling circular functions. So I know that these problems are pretty difficult and there's a lot of work involved in them. So it's really better if you just try to break it down into smaller steps. So what we talked about in Section 9 was breaking it down, first finding the amplitude, period, phase shift, and vertical shift. And once you find all those things, you can pretty much go from anywhere. A great starting point for the modeling problems is to make a detailed graph of your situation. And this will allow you to find the amplitude, period, phase shift, and vertical shift pretty easily. And then you can talk about the sine and cosine, which one you want to use as your parent function to make sure that you have the correct numbers. So the problem we've got our average normal temperatures in degrees Fahrenheit for 6 months of a year for Dodge City, Kansas. So the first thing I'm going to do is plot these data points using numbers for my months. So January will be 1, February will be 2, May is 5, July is 6, August is 8, and November is 11. Alright, so plotting these points, I'm going to put my month on my x-axis and my temperature on my y-axis. And for my months, I'm going from 1 to 12, so and then for my temperatures, my lowest temperature is 30 and I'm going up to 80, so on my graph here, I'll just call this 10, 20, 30, 40, 50, 60, 70, and 80. Alright, so graphing my points. Okay, so this is my graph, and now what I'm going to do is just kind of draw in my curve so I can get a better idea of what this graph is going to look like. So looking at this graph, I can see that my minimum point here is at 30, my maximum point here is at 80, so I can use that information to start thinking about how I can model this problem. So if I want to determine an equation for a periodic function to model these data, first thing I need to do is think about my vertical shift and my amplitude. So normally I'm going from -1 to 1. In this case I'm going from 30 to 80. Okay, so normally my amplitude is 1, whereas in this case I have a range of 50. Okay, so from 30 to 80 that's 50. So half of that would mean that I have a an amplitude of 25. Then I need to think about my vertical shift. So normally I'm centered around 0. In this case, I'm centered around this point here, right? So halfway between 30 and 80, that would be 55. So I'm centered around 55. That means my vertical shift is 55. Okay, so now before I can figure out my period and my phase shift, I need to decide whether I want to use a sine or a cosine function. I personally think that cosine functions are easier to use on modeling problems because we know that a cosine function starts at the maximum. And if I know what my maximum point here is, my maximum point is at month 7 and it's 80. So I can use that really easily to find my phase shift and my period. So I'm going to use a cosine function. Normally my maximum will be here at 0. In this case it's here at 7, so I can say that my phase shift is 7. And then for my period, well, I'm talking about months here. So there's 12 months in a year. That means that my period is going to be 12. Okay, so now I have to use all of those values, and I need to come up with an equation. So I need to know my A, B, H, and K values. Well, remember from my formula sheet, my B value is just the amplitude, so that's going to be 25. My K value is my vertical shift, so that's going to be 55. My H value is my phase shift, so that's going to be 7. And then my period, remember that I have to take 2 pi times A equals my new period, so my new period is 12. So if I divide that by 2 pi, and I simplify, I get 6 over pi for my A value. Okay, so now I have my A, B, H, and K values, and I can write my equation. So I'm going to say y minus K, which is 55, over B, which is 25, equals the cosine of x minus h, which was 7, over my A value, which is 6 over pi. And I'm just going to simplify that down so that it looks a little nicer. So if I move this 25 over, it can go here. If I add this 55, it can go here. And then right here, remember that dividing by 6 over pi is the same thing as multiplying by pi over 6, the reciprocal. So I'm going to rewrite that as pi over 6 times x minus 7, and then I'm going to distribute that through, so I'm going to get pi x over 6 minus 7 pi over 6. Okay, so now I've got my equation. Then it says, what does your model predict is the average normal temperatures for September in Dodge City? Well, September, that's our 9th month. So we're going to plug in x equals 9 into this equation here. So plugging that in, I'll have 25 times the cosine of 9 pi over 6 minus 7 pi over 6 plus 55. 9 pi over 6 minus 7 pi over 6, that's just 2 pi over 6, which is pi over 3. The cosine of pi over 3, if I think about my unit circle, pi over 3 is my 60. Okay, so if I'm looking for the cosine of that 60-degree angle, I would have 1/2. So this is going to be 25 times 1/2 plus 55. So that's going to be 12.5 plus 55, which is 67.5. So it predicts it to be 67.5 degrees in September. So this is just an example of one modeling problem. You're just going to apply the same strategies to all the other modeling problems in the section. And remember that it's really not that bad once you can find the amplitude, period, phase shift, and vertical shift. And that's everything for section 10.